So linear algebra solvers. Okay, so we'll work on this today, and I would at the outset I would mention that there are many important algorithms, important methods in linear algebra, but we'll cover only very basic ones. Okay, not so there's only one lecture, no? So we can only cover only basic ones. And this introductory course covering all algorithms. So it's natural that we give only limited space. Also, some books start with linear algebra, but I did not. I thought it's better to start with interpolation and develop up to differential equation. But okay, so anyway, here it is. So we need linear algebra in all branches of science and engineering. So quantum mechanics is one major place, right? Quantum mechanics is basically lots of linear algebra, linear vector spaces, and so on. Linear dynamical systems. So, also, for example, we write equation x dot. So x dot is ax plus by. Y dot is cx plus dy. So these called linear dynamical systems. So x and y are varying, but the right hand side only involves linear function of x and y. Okay, and very interesting properties can be derived for these equations, and this is essentially formulated in terms of linear algebra. Okay, in fact, x dot, y dot, or you can write this as the d by dt of xy is a matrix A times xy. Okay, you might have seen this before in classical mechanics, I'm sure, or quantum mechanics. Of course, we see this. Linear circuits in electrical engineering. Also, in the same course with splines, when we are working with, we had to solve tridiagonal matrix, solving implicit ODE solvers, or Poisson equation, which I did not cover for you all, but it requires that. Anyway, so we want to solve the equation Ax equal to B. A is given to me, the matrix, B is a vector, so I need to find what is x. Okay, that's the idea. So we find it all the time. Linear equations, we need to find unknowns. Okay, so we can write matrix A in this way, A00, A01, like that. So this n by n matrix, a small n by small n matrix. Okay, so the first, so start of course with index 0, Python, no, usual that we start with index 0 and go up to n minus 1. These are known, the x vector and b vector is known. Okay, so if you solve by standard method by using A inverse, you need to find A inverse, and the A inverse in standard algebra textbooks are written as adjoint divided by matrix, right? Sorry, determinant. And if you compute adjoint and determinant, it's order n to the power n. Okay, it's very expensive. So Gauss came up with an algorithm, okay, same Gauss, the famous mathematician, which is order n cube. Okay, so what is done here is the following. So you keep the first row. Okay, so basically, you may know from your algebra courses that equations can be multiplied by a constant. Okay, so you multiply all the A's and B by constant, it doesn't change, the solution is not changed, right? You can just multiply equation by a constant, doesn't matter. Okay, so you can subtract equation A from equation B. Okay, that also will not change the solution. Okay, so that's the idea, basic idea. So what we do here is that I want to eliminate A10, A20, eliminate all these entries. How will you do it? So we keep the first row. and I multiply the first row by, so I eliminate A00, okay, first. So divide by A00, all the entries, and multiply by A10. So overall, we multiply the first row by A10 by A00. So what happens to the first entry? That will become A10, no? First, this will become A10, A10, A00, so A00 cancels, I get A10. Of course, it is true, it's possible only when A00 is non-zero or finite number. Okay, if A00 is 0, then boom, it don't work. Okay, but if A00 is 0, then what do? I can exchange these two rows, and I can push A10 and make it the first row. Okay, anyway, so let's assume A00 is not 0, and then multiply all the entries of the first row by this, and so the first one becomes A10, and then subtract the second equation from the first modified equation. So the A10 minus A10 becomes 0, and this A11 is nothing but A11 minus A0. So that will be A11 minus, right? A01 multiplied by A10 by A00. Okay, so that is A11 superscript 1. Same thing for A12 and so on. Okay, the bottom line is I could set the first column or first entry of the second equation to be 0, and B11 is again follows from here, B1 minus B0 A10 by A00. Okay, so same thing we do for the third row, fourth row, and so on, and you eliminate, but of course you multiply here with A20. So for this time you have multiplied A20 by A00 multiplied by the first row and subtract. Okay, so this part is done. Now we have the matrix looks like this. After this, I want to eliminate these guys, these elements. So keep the diagonal, second diagonal, but eliminate anything below the second diagonal. Diagonal element, second diagonal element, second diagonal element here, A111. What will I do? I follow the same logic. I keep this row, but subtract here by A11. Well, exactly same idea. You just multiply and by a number and subtract. So these become 0. Then do the same thing for third column and so on. So keep doing it. So keep eliminating numbers, and lo and behold, we get, after all this elimination, we get upper triangular matrix like this. All entries below this are zeros. Okay, so they are diagonals and entries above the diagonals. Okay. Now this is Gauss elimination procedure. Procedure number 1, step 1. And step 2, well, now once we have it, is quite straightforward to see. Easily compute xn minus 1, right? What is xn minus 1? Xn minus 1 is this guy divided by this, right? Because it has only one element in that row. So this multiplied by that equal to this. So that is xn minus 1. Is bn minus 1 superscript n minus 1 divided by this idea. Okay, so xn minus 2 is known. What about the xn minus 2? Very easy. So here, remember there are two entries in this last second row. So that will be like this. So xn minus, this is a diagonal entry, an minus 2, n minus 2, n minus 2, and then the one here, this guy here, So an minus 2, n minus 2, n1 multiplied by xn minus 1 equal to bn minus 1. Okay, simple equation, no? Now we already know what is xn minus 1. This is known here, so I can compute xn minus 2. Okay, so this is called back substitution. So I substitute back xn minus 1 and compute xn minus 2. After xn minus 2, I go to the third row from the bottom, and there will be three entries here, here. Okay, but I already know xn minus 1 and xn minus 2, so I can compute xn minus 3. Okay, and that's how we solve for all x's. We can get them all, and this is Gauss elimination procedure. It's very easy. I mean, we can code it very easily in Python. How many multiplications are required in this, or multiplication, addition, subtraction? So focus on multiplication, which is the most complex operation. Okay, multiplication would take something like 4 times more than addition or multiplication, 4 or 5 times. Okay, so multiplication is the first time there will be so we had, if you recall, the first row, and then we had these guys, then these guys. So basically we have n minus 1 rows which are to be worked with, and you need to set all this to 0, but I have n entries here. Okay, n entries here. So n multiplied by n minus 1. Okay, there will be also involved, but okay, I'm basically getting the order. Then second time will be n minus 2 times n minus 1, and so on. Okay, so this is order NQ. Okay, we'll have n such entries, so you can see that each of them is order n squared, and multiple of n is order NQ for elimination. What about back substitution? Back substitution, first time, the last row. Remember, last row I had only one operation. After second last row, I had two operations. Third last row, three operations. 1, 2, 3, like that, n minus 1. So this sum is order n squared. Okay, so together NQ plus n squared, order NQ. Okay, so Gauss elimination is order NQ. Okay, so if the matrix is full, it's not sparse. So one more word you will come across is sparse matrices where there are many zeros. But if the matrix is not sparse, almost full, I mean there are very few zeros, then this solution of X requires order NQ operations. Sparse matrices require less, but we will not do it in this course. Okay, example. So we have this matrix A. I need to solve for X, and this B. So what do I do first? I get rid of this 3. For that, what should I do? I multiply by 3 in the top and subtract the first row by the from the second row. So 3 minus 3 is 0. This 2 minus 3. 2 minus 3 is minus 1. This becomes 0, so remains 1. And here 3 times 3 is 9. 10 minus 9 is 1. Okay. Here I need, well, this 0 is already, I mean, this entry is already 0, so don't do anything. If it's 0, then don't do anything. So this row remains as is. Okay. After this, I need to get rid of this minus 1. No, sorry, this 1. Get rid of this 1. How will I do it? In fact, it's easy right now. I just add the second row with the third row, and that gives you 0. 1 plus 3 is 4, and 1 plus 11 is 12. Okay, now it's easy, no? So what is x2? From here, 4x2 is 12, so x2 is 3. Then I go here, minus x1 plus x2 is 1, but x2 is already 3, so x1 is x2 minus 1, which is 2. 3 minus 1 is 2. Then I go here. Okay, so this is x0 plus x1 is 3, but x1 is 2, so x0 is 1. Okay, so my answers are 1, 2, and 3. Okay, so that's answer 1, 2, 3. Okay, so this is how we work with Gauss elimination.